x is equal to b. If you simply reading that as a simple equation, then you are not looking at a system of linear equations. You are not using linear algebra. Remember, we've come across this many times before, where A is the matrix, X, the vector X is the unknown vector, and the vector B is the constant vector. And there could be any number of linear equations in any number of unknowns. And then looking at the solution as given by determinants. Now you know how to calculate the determinants. The only difference here is that somehow or the other, we need to figure out what do they mean by, when we are finding x1, determinant a1. We know that the determinant of A is simply that matrix there, taken from that equation. But what do we mean by determinant A1 or determinant A2? Well, here they stipulate AJ is the matrix obtained by replacing the entries in the jth column of A by the entries of the matrix B. And of course, B comes from there. So in essence, to find if it's X, Y, Z, or I1, I2, I3, we find determinants and simply use this formula. Determinant A1 over determinant A. So let's put it into practice. Let's look at a 2x2 example, just to see and to show you very quickly how to use Cramer's rule. So solve the system of equations. There's the equations. So here we have two unknowns, x and y, and two equations. Now, firstly, is that in the correct form? No, it isn't. So let's reset by transposing and getting the equations in the correct form. So taking the plus 19 and the plus 17, transposing, I get equation 1, equation 2, our system of equations. Now, yes, we can use the method we used at school, but of course, we are not going to do that because that's a method that is quite easy for two variables. The moment we go into 3 and more variables, we get really complicated. So what's the first thing? When you have those two equations, write in matrix form. Now we know how to do that. So writing that in matrix form, 5, 3, 2, 4, there you go, 5, 3, 2, 4, the unknown variable xy, the constant variable vector, sorry, minus 19, minus 17. So that is the form ax equal to b. So what is a? A is 5, 2, 3, 4. There we have my a. What's the unknown vector x? The variables are x and y. What's the constant vector? Minus 19, minus 17. Now all I have to do now is find determinants of those. But we have to be careful. Let's see why. So from our previous slide, where we have x1, for instance, x is equal to determinant a x over determinant of a. We need to find what a is and what ax is. So let's get back to the slide. Well, there's a. We already know what a. So we simply take that matrix, find the corresponding determinant, and we all know how to do that. 5 times 4, subtract 3 times 2, and I get 14. Now, what does determinant ax mean? Well, the theory states that what you do, if you want to find the determinant of a subscript x, then you look at the matrix of A, which is this, and identify which column the x's, which coefficients was from the x. And we know from the original equation that the first column is the x column. Therefore, the first column in A is 5, 3. So what is AX? We remove that 5, 3. So we're going to take, let me just go back to the page, 5, 3, there you go. Take that away and take the constant vector and put it in its place. So taking the constant vector and putting it in the place of 5, 3, I get minus 19, minus 17, and the 2 and 4 stays right there. And I simply find the determinant, minus 19 times 4, subtract 17, minus 17 times 2, and I get minus 42. So that's what I did. I replaced the first column x by the constant vector b. Remember, this is your constant vector b. So there I have determinant ax. A y follows the same pattern. So getting into a y, let's just erase this. Now what do? I take my y column away and replace it by the constant vector, minus 19, minus 17. So 5, 3 stays where it is. There's 5, 3. And the y column is now replaced by minus 19, minus 17. And then just find the determinant. 5 times minus 17, 3 times minus 19, and I get negative 28. Now, once you have calculated the determinants, now you use the formula, and this is Cramer's rule. Where if you want to find x, it's determinant ax divided by determinant of a. What's determinant of ax? Negative 42. What's determinant of a? Divided by 14. Work it out. There you get the value x equal to minus 3. If we want to find y, it's determinant ay. Notice the denominators is the same determinant of the original matrix without replacing anything. Substituting determinant ay, minus 28 over 14, I get y is equal to minus 2. So in essence, Cramer's rule is simply working with determinants. Now, what is the case? You're going to get, obviously, 3 unknown quantities, x, y, z, 3 equations. Let's solve this system of equations using Cramer's rule. So what would your formula be? In all the cases, for x, it will be determinant ax divided by determinant a. Y, z, can you write that down before I do? What would y be? Determinant a y divided by determinant of a. And z, the determinant a z divided by determinant of a. Which means I need to calculate all those determinants. The determinant of what? First step, write this in matrix form. So our matrix form, and we know how to do that now. There's my A, there's my constant, my unknown vector, and there my constant vector. What are the coefficients? 2, 3 minus 1, 3, 1, 2, 1, 2 minus 5. What are my variables? X, Y, Z. And my constant vector 4, 13 minus 11. There's my A, there's my unknown, and there's my constants. So what do I need to calculate? Well, I must find determinant of A, which of course is using the vertical bars. In this case, it is 2, 3 minus 1, 3, 1, 2, 1, 2 minus 5, expand, and I have chosen the first, which one? No, I've chosen the first column, so I've gone that way. So it will be plus 2 times, and by now you can surely do this all at once. 1, 2, 2 minus 5. The 3, the place sign is minus. The 3, what's the minor of 3? Block, block. 3 minus 1, 2 minus 5, then plus minus plus. You know what I'm doing? I'm looking at the vertical, the place signs, plus minus plus. So that will be a plus. What's the value? It's 1. And what's the minor? Work out the minor, block out the row, block out the column. 3 minus 1, 1, 2. I would like you to verify that. I get an answer of 28. So there's my determinant of A. Now I must find determinant AX, determinant AY, determinant AZ. Now what I'm going to do is simply write down those determinants and the corresponding answer. I need you to verify that because it's repetition and it's also accuracy. However, what I'm going to concentrate on making sure that you write down the correct determinant. So if I want to find determinant AX, X is the first column. So I take the constant vector, remove the first column, and put the constant vector in the place of the first column, which is the coefficients of X. So it will be 4, 13 minus 11. What happens to the rest? The rest remains the same. 3 minus 1, 1, 2, 2 minus 5. Work that out, you will get an answer of 56. And I'm pretty sure by now you have already found a much shorter way of finding those determinants, eh? You have calculators, you have Google, you have so many options. Let's find the next determinant, AY. Now what do I replace? Now I have to leave. Remember, I'm looking at the original determinant of A. Now I'm replacing the second column. So the first column stays the same. 2, 3, 1. Y is in the second column. Remove that second column, replace it by the constant vector, and leave the remaining column. And I get an answer for AY of 28. And then determinant AZ. Now I must leave the first and second column. So it's 2, 3, 1, 3, 1, 2. Replace that. 4, 13 minus 11. I get an answer for AZ of 84. Now that I have all the determinants, all I have to do is use Cramer's rule. So for x, it will be determinant ax over determinant of a, and that is 56 over 28. That gives me 2. For y, determinant ay over determinant of a, 28 over 28, that is 1. Z is equal to determinant az over determinant of a, and that is 84 over 28. That gives me an answer of 3. Therefore, and I can do this vector depending on the notation. I could say x, y, z, like a triplet, is equal to 2, 1, 3, or I can use the notation of a vector x, y, z is equal to 2, 1, 3. And that is your solution of simultaneous equations by Cramer's rule. Now, to complete this particular section as far as determinants are concerned, I just want to quickly add a property of linear equations, and that concerns consistency. Now, we've come across this before. So it's consistency of a system of linear equations. Now, in essence, by consistency, we mean, is there an answer? Is there a unique solution? Does it have a solution, a unique solution, or possibly infinite solutions? Inconsistent means it has no solution. So how can we quickly check that a system that's given to you is consistent? Well, we say that a system of equations they are consistent if the determinant of that matrix A is equal to 0. So by consistent, we mean that there is a common solution. So, for example, is the following system 3x minus y minus 4 equal to 0, 2x plus 3y minus 8 equal to 0, x minus 2y plus 3 equal to 0. Is this system of equations consistent? What do we need to find? The determinant. But I want you to look very carefully at those equations that I've written down. Do you notice that the right-hand side is 0? Do you also notice that there are 3 equations, but how many unknowns? There's only x and y. There's 2 unknowns. So how do we go about solving this? Remember, to solve a system of equations of two unknowns, we only need two equations, but here we have three equations. So I can choose any two of those equations and solve for x and y, as we did in school. But how would I know that the solution I get also satisfies the third equation? In other words, are there values for x and y that satisfy every single one of those equations? How can I check? I can check by finding the determinant of A. And what is the determinant of A? Very straightforward. You simply ensure that the constant vector is 0 and then write down the corresponding matrix and find its determinant using the coefficients 3 minus 1 minus 4, 2, 3 minus 8, 1 minus 2, 3. Find that determinant, and in this case you can check that. Expanding along the first column, I'm going to get 3 multiplied by, what's the minor? 3 minus 8 minus 2, 3. Then 2, the place sign is minus, the minor of 2 minus 1 minus 4 minus 2, 3. Then 1 and the place sign is in. Remember, I'm expanding along the first column. What is the minor of 1? Minus 1 minus 4, 3 minus 8. And working that out, I get an answer of 21. So is it consistent? Not at all, because it is not equal to 0. It's only consistent if the determinant is equal to 0. Therefore, the system of equations is inconsistent. In other words, no solution. It's not consistent. I can give, let's make that one the first example. The second example, the equations 3x plus y minus 5 equal to 0, 8 equal to 0, x minus 2y plus 3 equal to 0. What's the matrix? Will be 3, 1 minus 5, 2, 3 minus 8, 1 minus 2, 3. Find the determinant, and when you do that, you will see that this gives you an answer 0. Therefore, we can state the system is consistent. In other words, we can find solutions for that system of equations. That completes this video.